Hello, today I will be talking about the gas biofuel, which is ethanol. So what is biofuel and what is ethanol? Biofuels are renewable energy sources, typically originating from biomass like plant material and animal waste. Ethanol specifically is a liquid biofuel produced from fermenting plant sugars and starches. It is one of the most common biofuels used today, and its most common usage is as a gasoline enhancer. So what is the process of production? Ethanol production starts by using carbohydrate-rich crops, which are first grown and harvested. This might be corn, which is typically used in the US, or it could be sugarcane, barley, sorghum, or other materials. This raw material is then processed into a simple sugar like glucose, and then we add yeast to start fermentation, which metabolizes the sugars into ethanol and carbon dioxide. The resulting liquid, which is a fermented beer, is distilled into about 95% pure ethanol, which is 190 proof alcohol. And then to reach the required concentration for application in industry, it is then dehydrated, which will produce something close to 100% pure ethanol. If this ethanol wants to be used as a fuel additive, the ethanol goes through something called denaturation, which is basically adding some contaminant like natural gasoline to render it undrinkable, and then it is ready to be mixed into gas. So what is the development status of ethanol? Ethanol is already widely deployed in various industries. Synthesizing first-generation ethanol, which is the process in the slide before, is already a very mature process. The US recorded a record 16.2 billion gallons produced in 2024. And there is this other process called cellulosic ethanol, which is still under research and development. But what's great about this type of ethanol synthesis is that it can be made from grass, wood, or other agricultural waste. And because of that, it's more complex and costlier, but it does have lower carbon footprint. Regarding the carbon footprint of producing ethanol, it largely depends on how the raw materials required for synthesis of ethanol are acquired. So it largely depends on feedstock, land use, and agricultural practices. Right now, many assessments show that the reduction of carbon footprint when compared to just using pure gasoline is modest. However, continued improvements in agricultural efficiency and practices will gradually decrease the carbon footprint of producing ethanol. Usage of sugarcane-derived ethanol, however, achieves a better carbon footprint compared to, let's say, corn, because growing sugarcane is far more space efficient and it produces higher yields. Cellulosic ethanol has the potential to have significant carbon footprint reductions or even have net negative carbon footprint because it typically uses agricultural waste or dedicated energy crops which provide carbon more sustainably. What about the economy? The ethanol industry is actually key to the US economy, contributing about $53 billion to the US GDP in 2024. It also provided over 300,000 full-time jobs, and it supports the agricultural sector by increasing demand for corn and other raw materials required for production of ethanol. And there's a co-product of the ethanol production called distillers dried grains with solubles, or DDGS, which is a high protein animal feed. So that animal feed goes back to the farmers and they can use it to feed their animals, further supporting the agricultural sector. Regarding public communication, federal regulators and agencies like the EPA and the USDA communicate about the benefits of ethanol mixed gasoline. So benefits are typically lower carbon emissions or cost of fuel or cleaner engine operations. There are also efforts to educate owners of E85 fuel-compatible vehicles, which are typically FFVs. They can use the higher concentration ethanol blended gasoline, which is 85% ethanol fuel, which is significantly cheaper and better for the environment. In analyzing ethanol, ethanol is obviously a mature commercially deployed biofuel that has numerous benefits for both the environment and consumers. The next steps should be continuing to innovate cellulosic ethanol to extract maximum carbon and economic benefits, further educating the benefits of using high ethanol fuel blends, and to prioritize high-yield crops in use for ethanol production. If cost was not an issue, my plan of action would be to start large-scale construction of cellulosic ethanol-producing infrastructure, start comprehensive programs that support efficient and sustainable agricultural practices, and inject more funds into research and development of ethanol-producing technology. These are my citations, and thank you.